Hi everyone, we have to find solution using axiomatic probability. A given in the question probability of A is equal to 0.4, probability of B is equal to 0.5. Then probability of A union B is equal to 0.8. Find probability of A intersection B. For axiom, we have one formula which is very important. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Probability of A and B is equal to 0.8, 0.4 plus 0.5 minus probability of A intersection B. Then 0.8 is equal to 0.9 minus probability of A intersection B. Then probability of A intersection B is equal to 0.9 minus 0.8, which is equal to 0.1, which is not equal to 0. So we also check A and B are mutually exclusive or not. We have to check probability of A intersection B is not equal to 0. We can say that it is not mutually exclusive because probability of A intersection B is not equal to 0. So A and B are not mutually exclusive. And I have also given one important note, that is, if probability of A is not equal to 0, 1, then probability of A bar by B bar equal to probability of A complementary intersection B bar by probability of B bar, that is equal to probability of A union B bar by probability of B bar. Then we can write as probability of A bar by B bar is equal to 1 minus probability of A union B by probability of B bar, because probability of A union B plus probability of A union B bar equal to 1. So it is a very important note regarding axiomatic probability. Which is the previous year net question, that is, if A and B are mutually exclusive events such that probability of A into probability of B is greater than, only greater than, so they are given 4 options, which is correct. If A and B are independent Second one, A and B are not independent. 3. A subset to B, 4. B subset to A. Then which is correct? They asked. So if A and B are mutually exclusive events, but events as a probability of A into B is greater than 0, then we directly say that probability of not independent, because probability of A intersection B is equal to 0, that is not equal to probability of A into probability of B. Due to non-independent, because of mutually exclusive. If it is not mutually exclusive, probability of A intersection B is not equal to 0, but here probability of intersection B is equal to 0, we can say mutually exclusive. And one important note is that in axiomatic probability, which is always lies between 0 and 1, and the probability of sample space, that is equal to 1. Okay, thank you for watching this video in 1.5x. Please watch in 1.5x, and we have to meet in next part with 5 more example problems.